47 degrees Celsius, wind speed 80 kilometers per hour, visibility under 5 meters. Sahara sandstorms can sustain these speeds for 6 to 8 hours uninterrupted. Without shelter, core body temperature drops dangerously as sweat evaporation ceases in dry heat. 12 hours earlier, the GPS read 31.1 north, 4.02 west. Ouga sits at 860 meters elevation, the last reliable fuel stop before the Algerian border. Total water carried, 18 liters. Estimated crossing time is 4 days to the Tassili Plateau. Map shows no marked trails past this point. Satellite imagery ends at the Algerian military exclusion zone.
First step onto the erg. Sand temperature, already 32 degrees at sunrise.
These dunes migrate 11 meters per year, driven by the prevailing northeasterly Harmattan winds. Grain size here averages 0.25 millimeters, fine enough to fluidize under sustained wind. Standing at the edge of a slip face triggers granular convection, the sand behaving like a slow liquid. The goal is 200 kilometers southeast, where satellite data shows an anomaly no one has explained. A body of water appearing and disappearing over decades in the most arid corridor on Earth. Kilometer 12. The erg gives way to a stone plateau called the Hamada. Hamada surfaces are 95% exposed bedrock, formed by wind stripping all loose sediment over millennia. The border crossing here is unmarked. Algerian military patrols cover this sector roughly once per week. Kilometer 38. First sign of the Tadrat Rouge formations, iron oxide sandstone. The iron content in these sandstones reaches 12%, creating the characteristic deep red oxidation layer. Kilometer 52. Entering a slot canyon system carved by flash floods over 10 million years. Finding a flat spot for the first night. Temperature dropping fast, maybe 15 degrees in the last hour. Temperatures here can reach 8 degrees. Hypothermia risk is real, even in the Sahara. Day 2. Coordinates now 30.6 north, 3.2 west. Heading due south toward the Tassili Plateau. Distance covered since dawn, 14 kilometers. Water consumed, 3.5 liters. 70 kilometers in, the terrain shifts to reg desert, cobblestones of iron meteorite origin. The Tassili Plateau has yielded over 15,000 meteorite specimens, making it the densest collection zone on Earth. The sandstone spires of the Tassili rise abruptly from the reg, some exceeding 300 meters. Day 3 dawn. The cliff base shows evidence of ancient water flow, channels carved into solid sandstone. The ancient channels carved deep into the sandstone tell stories of water that flowed here thousands of years ago.
The Tassili Plateau holds over 15,000 prehistoric rock engravings, spanning 8,000 years of human occupation. The engravings show hippos and crocodiles, species that vanished from this latitude over 5,000 years ago. From 9,000 to 5,000 years ago, supported a human population density comparable to modern Europe. Then the monsoon shifted south 400 kilometers. The lakes dried. The people migrated or perished.
Kilometer 90. The plateau opens into a forest of stone pillars, some shaped like mushrooms. The mushroom shapes form because wind erodes the base faster than the harder cap rock above.
Wind speed on the plateau averages 25 kilometers per hour, enough to sandblast stone at 0.5 millimeter per century.
A dried riverbed crosses the plateau. Ancient granite cobbles mixed with sandstone pebbles. The granite cobbles originate from the Hogar Mountains, 200 kilometers southwest, carried here by ancient rivers. This river stopped flowing 4,000 years ago, but its bed remains the only natural corridor through the plateau.
The Tassili receives less than 20 millimeters of rain annually, yet some lichen species persist on north-facing surfaces.
Night camp, day 3. Coordinates 28.4 north, 2.1 west. Distance to target, 80 kilometers. Water remaining, 9 liters. At current consumption rate, that is 48 hours of walking. Day 4. The plateau edge descends toward the Merzouk Basin. Elevation drops 800 meters over 60 kilometers. The Merzouk Basin is one of the most remote regions on Earth, an area the size of France with 0 permanent settlements. The satellite anomaly I am tracking sits at the basin's center, where no water should exist. Kilometer 120. The basin floor is erg sand again, but darker, finer, almost volcanic in appearance. The dark color comes from magnetite and ilmenite, heavy minerals concentrated by wind sorting over thousands of years.
Sand dunes produce a low-frequency hum called singing sand, occurring when grains shear against each other at resonant frequency.
Kilometer 140. Something is wrong with the wind. It shifted 90 degrees in the last hour. Barometric pressure dropped 8 millibars in 30 minutes. This is not normal diurnal variation. Visibility dropping to 50 meters. Wind speed estimate
60 kilometers per hour and rising. The sand wall is a haboob front. Cold, dense air undercutting warm surface layer lofting 10 million tons of sediment. Inside the haboob, visibility drops to under 2 meters. Disorientation onset is typically 90 seconds.
The haboob front advances at 40 kilometers per hour. A moving wall of sediment 400 meters high. Haboob duration in the central Sahara averages 4 to 6 hours. The sand load can exceed 600 milligrams per cubic meter. Electrical activity within Saharan haboobs is common but poorly understood, with voltage gradients reaching 10 kilovolts per meter.
4 hours inside. The wind is dropping. Visibility extending to maybe 10 meters now. Water remaining, 2.3 liters. Skin on forearm shows grade 2 abrasion from sand impact. GPS still functions. Distance to anomaly, 12 kilometers. I can make it before dark if I move now.
Post-haboob settling takes 2 to 3 hours. Sand particles undergo size sorting, with finest silt remaining airborne longest.
Kilometer 168. The GPS is leading me into a depression. Sand is changing color, becoming lighter. The lighter sand indicates groundwater influence. Quartz leaches color when moisture persists beneath the surface. Kilometer 172. I see green. Not possible. That is not possible at this latitude and elevation. Date palms do not grow at 460 meters elevation in the Merzouk Basin. The groundwater table here should be at 80 meters depth. I am walking towards something that every geological survey says cannot exist. The water is sulfur. I am sitting in an oasis that has no right to exist. The fault line must run deep, tapping a fossil aquifer from the Green Sahara period, pressurized enough to reach the surface. Final morning. The sun rises over the phantom lake, and for a moment the desert remembers it was once a garden. The oasis exists because a crack in the earth remembers where the water used to flow. The land remembers. Maybe we forgot.
The phantom lake may vanish again within a decade, as the fossil aquifer slowly depletes, returning this basin to silence.